NA Physics, it's Mr. Neff. Let's keep on going with this adding and subtracting vectors homework problems. 25 says vector A has a magnitude of 27 meters and points in the direction 32 degrees above the positive x-axis. So just real quick sketch, something like that. Vector B is 35 meters and points in the direction 55 below the positive x-axis. So longer, I guess, something like that. Now they want you to sketch the vectors A, B, and C, but then they want you to estimate the magnitude and direction of C, which is A plus B, from your sketch. Well, this really crude sketch shows you that it looks something like this, but you know, I don't know how valuable that is. I mean, I can see that it points down and to the right, but how valuable is that? So what they really want you to do here is do a little more careful measurement. So what I'm going to do is I'm going to use a protractor here. Let's see if I can line that up right on one of those grid lines. That's pretty good. Now, the vector A was up at 32 degrees. So 32 degrees from the origin. Origin's right there. 32 degrees would be like right there. And then vector B is at 55 degrees below. So 55 degrees would be 10, 20, 30, 40, 50, 55. Be like right there. Okay. All right, so then what I'm going to do, so that I have pretty good looking angles. Now, I'm supposed to draw 27 meters. So I'm going to take this ruler. I'm going to put it there like that. I'm going to try to spin it so that I get this right on the... This is much easier with a real ruler, right? Okay, something like that. Now what I'll do is I'll draw that 27 meters long. Now I'm going to make a pretty good big picture, so I think I'm going to go double 27, so that would be 5.4. So I guess my scale in this picture is going to be 1 centimeter equals 5 meters. So I'm going to try to draw this pretty straight. 5.4. You know what? I don't like that very much. One more time on that. 5.4. That looks pretty good. A little wiggly, but it's okay. Now, similar thing with the 35 at 55 below. So I'm going to do the same thing. Turn this. Again, this would be easier with a real ruler. Pretty good. Now that was 35, so I want to draw this 7 centimeters long. Oh, gotta have it as one piece. That's pretty good. All right, and so now, similar to what I did with my sketch before, I'm going to take this, I'm going to scooch this up here like this. Okay. Now my resultant is going to be this right here. Okay. And the way they want you to do this from the sketch is they literally want you to measure this thing. Now, you might be a bit turned off by this, and we're going to do this with components, and it will be something that's a little bit more reliable. But all in all, this isn't the worst thing a person could do. Okay, so it looks like I have a length of that black one, 9.35 centimeters. Try to get a guess digit in there too. And so 9.35 centimeters times the scale, 1 centimeter is 5 meters. So that would be 46.75 meters. Okay. And then they also want the angle. So I could take this protractor, I could place it in here, the way I did before. There we go. And so now you can see this resultant from the x-axis. There's the positive x-axis right there. It looks like it's down 10, 15, 19 degrees, something like that. I'm going to call that negative 19. Negative because it's clockwise negative 19 degrees. So my final answer on that then is going to be 46, two significant figures. I'll round that to 47 meters at negative 19 degrees, or 19 degrees below the positive x-axis. Now, yeah, the truth is that would probably turn you off. That would probably make you think, like, oh, that's, how reliable is that answer? Well, I'm glad that you would think something like that. See, in number 26, it says do that same thing, but use the idea of components. So, kind of zoom in this so that we can see both of them together. Maybe I'll bring this over here. So that blue one, it has components. That red one, it has components. And we could mathematically add the components together very easily. What we could do is we could say, okay, the blue one, it has components that look like this. It's like the blue X. I'm going to be picky about that. I'm going to draw that just a little less. And we have the blue Y. So X component, Y component. And then we would have the same kind of thing over on the red one. We'll say that the red one has a negative Y. Goes like that. And it has a positive X. It goes like that. Okay, so I know from the given that this angle over in the blue triangle is 32. And they gave me in the given that this angle right here was 55. So I'm going to say this is 35. Now, the two hypotenuses, 27 meters and 35 meters. So see what I could do here. I could say the blue one is, well, has a 27 cosine of 32 degree x component and a 27 sine of 32 degree y component. When you put those into your machine, you're going to get 22.9 meters for that x component, and you're going to get 14.9 19.3 meters for the y component. For the red one, we're going to do something similar. I think you should stop the video here, and I think you should try to get those two for yourself. So please stop the video now. Try to get the x and the y components. Use the 35 degrees, use the 35 meters. Okay, we're back. And so for the x component, that x is not touching the 35, so it's going to be the sine, and so it's going to be 35 meters. Technically, these were meters over here, too. 35 meters sine of 35 degrees. And the y component is 35 meters cosine, that's touching the 35 degrees. So when you look at the cosine component, that's the y, that's going to be 28.7 meters. And when you look at the x component, which is the sine one, that's going to be 20.1 meters. Now see where I am? If I want to add those two together, I could say the blue one is 22.9 meters x hat and 14.3 meters y hat. Now the x velocity, the red vector is going to be 20.1 meters in the x direction, but the y component is down, and that's going to be 28.7 meters y hat, and that is going to be negative, so it's down. So see what you could do then? You could then just simply add those columns together. Now I'm going to get a, with that, 0.0 carry to 1, 3, 43 meters in the x direction. And I'm going to get, that's a subtraction there, that's going to be negative 14.4 meters in the y direction. Now, if you put those two together, so 43, and this is not drawn to scale very well, 43 meters there, and 14.4 meters here, the hypotenuse is going to look like that. So Pythagorean theorem is going to give you 45.3 meters, which is pretty close to what we got on the before. And if you find that theta right there, that's going to be an arctan. That's going to be an arctan of 14.4 divided by 43, which comes out to 18.5 degrees, which I had 19 before. 18.5 looks pretty good. So in this way, I got 45 meters at negative 19 degrees, pretty close to what I had last time.